Actually do some differentiation. We talked about what it is last episode. Here's how you differentiate using the power rule. This is what they start to look like. Again, we're only covering one strategy out of the many different ways of differentiating. We're only covering this first strategy, the power rule. So, the original functions are up top. So if we had f of x is equal to x squared, the derivative is f prime, is we use those apostrophes after our function's name to say that we have a derivative. F prime of x is equal to 2x is the derivative of x squared. X to the negative third becomes negative 3x to the negative fourth. Then 5x to the seventh becomes 35x to the sixth. So let's go through, break down each of these three examples, examine two special cases, and then you will be a master of the power rule for differentiation. So if we take a look at this one, here are the steps. Take the exponent and make it a coefficient. So we're going to bring that 2 down in front of the x, so it's a coefficient, a number attached to the front of the x, being multiplied to our variable. Then we take the original exponent and subtract it by 1 to find the new exponent. The original was 2. 2 minus 1 is equal to 1. But wait, there's not a 1 right there. Well, that's because we need to remember our basic exponent rules. Anything to the first power is just being multiplied by nothing. It's just standing there all by itself, so we don't actually need to write that invisible one, and that's why it wasn't there to begin with. But I wanted to make sure I showed it to you and explained that exponent rule. Let's see what this looks like. Same two steps, just with a negative exponent. X to the negative third. Step 1 is still the same. Make the negative 3 a coefficient. So we bring that down in front and we get negative 3x. Step 2, subtract the original exponent, negative 3, by 1 to get the new exponent. So negative 3 minus 1, going down, going to the left on that number line, is negative 4. So negative 3 minus 1 is negative 4, and that's where we get our new exponent. And that's it. Negative 3x to the negative fourth is the derivative. Now, what if there was a number in front already? What if there was already a coefficient? Well, let's talk about it. Let's do the same two steps. Make the 7 a coefficient. So we bring the 7 and make it a coefficient to the x. And then we subtract the original exponent by 1 to get the new exponent on our variable. 7 minus 1 is 6. So we end up with 5 times what we would really expect, 7x to the 6th as the derivative. Well, we need to use our properties that work with multiplication. In this case, it's the associative property that lets you change where the parentheses of a multiplication problem are. So instead of having the 7 and the x to the 6th grouped together, we can instead group the 5 and the 7 together and multiply them. 5 times 7 is 35x to the 6th. And that's where the derivative comes from. Two more special cases we need to do. Original function we talked about. Well, let's follow the usual steps. Make the invisible, this time 1, a coefficient. So we get 7 times 1x. Looks a lot like our last example. Subtract the original exponent by 1 to get the new exponent. Well, 1 minus 1, mind-blowing, it's 0. So 1 minus 1 is 0, so when we rewrite this, we get f prime of x is equal to 7 times 1 times x to the 0 power. We regroup using that associative property like we did last time. 7 times 1 is 7. So we end up with 7x to the 0. Again, exponent properties coming in very important right now. x to the 0, anything, any number to the 0th power is always equal to 1. So 1 times 7 we don't need to write because anything times 1 is itself. So really, when anything is being raised to the first power, when our variable is raised to the first power, that variable ends up essentially disappearing. We just drop it. We ignore it in our derivatives. So 7x as the parent original function becomes just 7. What if there is no variable? If there's no variable, the power is 0. So that's pretty much it. When we bring down the coefficient of 0, so if we had that x to the 0, we bring that down in the first step. 5 times 0 is 0. So if there is no variable, then the derivative is always equal to 0. And that'll do it. That's it. That's all you need to know about the power rule. So we're going to keep on moving and start to get back into some stuff that I hope you're here for.